This is an example of what we call stoichiometry. Stoichiometry is an essential part of chemistry. It deals with ratios of reactant amounts to product amounts. You never can just mix random amounts of chemicals together and expect for a reaction to go to completion. And I've put an example on the board of a common demonstration that we oftentimes do in chemistry. Let's say that we have 0.2 grams of magnesium, and I want to know how much hydrochloric acid would be needed in order to make this reaction go to what we call completion. All right? In stoichiometry, it's real simple. You always start by writing down the number and the unit of what's being given in the problem. So if my question is, given 0.2 grams of magnesium, how much hydrochloric acid will be needed, then I'm going to start by writing down 0.2 grams of magnesium. Now, I want to get rid of grams of magnesium, and I need to add a little G for grams. And I want to convert my grams into moles, and we'll see why we need to do that in just a second. All right, real simple. We put the grams of magnesium on the bottom so that they'll eventually cancel out. Now, this is what we call a conversion factor. This must be a true statement. I can always go from grams of any atom or element into 1 mole by looking on the periodic table and writing down the atomic mass for that element. Magnesium has an atomic mass, if you look at the periodic table, of 24.3 grams. Now, the grams cancel, and we're left with moles of magnesium. But ultimately, I want to know how many grams of hydrochloric acid can be made. So the next calculation will be what we call a mole-to-mole ratio based on this balanced equation before you here. I want to get rid of moles of Mg and get it, or convert it rather, to moles of hydrochloric acid. We go by the coefficient within the balanced chemical equation. For every 1 mole of magnesium, you always have 2 moles of hydrochloric acid reacting. So it's a 1-to-2 ratio. So for every 1 mole of magnesium, 2 moles of hydrochloric acid react. Again, we cancel our identical units. Moles cancel with magnesium, and moles with magnesium cancel here. Now, our last step is to convert moles of hydrochloric acid into grams. 1 mole of hydrochloric acid, we just said earlier in this section here, you just add the total atomic mass using your periodic table. We have 1 atom of hydrogen and 1 atom of chlorine. The total atomic mass is 36.4 grams. And again, always scratch out, mark off the unique, the identical units. So moles cancel, moles cancel. All right, and I should be left with what I need. The original question was, if given 0.2 grams of magnesium, how many grams of hydrochloric acid would be required? So all we have to do now is just do the calculation. 0.2 times 2 times 36.4, put that in your calculator, hit equals, and then divide it by our product of our denominator, which is 24.3. And you should come up with 0.6 grams of hydrochloric acid would be required if given 0.2 grams of magnesium. So 0.6 grams of hydrochloric acid would need to react with 0.2 grams of magnesium if you would want this equation or expect this experiment to go to completion. And that, again, is an example of stoichiometry, ratios of reactants to products.